This is the first in a two-part series covering the Delta5 Race Timer. This specific video is covering the hardware build instructions. My next video will cover the software portion. This build is based off the PCB that was designed by Robert Faron in the Delta5 Race Timer group on Facebook. These are the RX5808 receiver modules. We'll be using 6 of these in the build, and you can see them. They're clearly denoted by the markings on the board. These are the Arduino Nanos. We'll also be using 6 of them, also marked on the board. We'll be using 6.01 microfarad capacitors. We'll be using 6 100k ohm resistors in these spots. We'll be using 18 1k ohm resistors in these locations. We'll be trimming 1x20 header pins for these power jumpers for the Arduinos. Here you'll be able to see how we're using the little jumpers and how they fit on the pins, basically once they're installed. This is a Traco 3.3 voltage regulator, and it goes here. The ever popular Raspberry Pi 3, and it goes here. Here in this next clip, you can see me using the PCB to start soldering the Arduino Nanos. I'm just using it to facilitate and make it easier to hold it in place while I tack down a few pins, and then I simply just go pin by pin, slowly making sure I don't need to apply too much heat, touching each pin and a little bit of the Arduino Nano so I seat correctly. Here you can see I tack the first few pins, and I simply flip the board around just to make it easier to solder. I'm right-handed, so it's just a little easier and less clumsy for me to flip it around than to potentially burn some components. Same technique applies in and out. I don't spend a lot of time on each pin. Just careful not to overheat the board and the components. That's all you have to do here, just take your time. In the interest of time, I've shortened this in a time lapse, and you can see me basically adding nanos to the board one by one. We're going to be dropping in these 0.01 microfarad capacitors in these slots shown. It's a little tricky getting them in there. They do have little points where they kind of grab onto the sides and make it a little easier for you to drop them in the slots, and they hold into place while you solder. Here in this portion, I've installed all the capacitors. You can see that I bend the little legs outwards to kind of keep them fixed in place while I'm on the back side of the board here soldering them. So here you can kind of take a look how they're situated. Here you can observe me soldering these caps in place. I simply just do each leg one at a time, about 6 to 650 degrees. Taking my time, doesn't take a lot of heat, it's really quick in and out. And then I simply go through and clip the extra portions that are no longer necessary to keep the board clean. Here you can see all 6 caps installed cleanly. Now we're going to do the 1K resistors for each one of the modules. Here you can see I dropped in the 1K resistors, similar to what we did with the caps in some of the previous clips. Same technique is used here. We spread the legs for the resistors to make it easier so they hold in place while we go ahead and tack each one down. Just make sure they're well in place, and you can always heat them up and push them from the opposite side to make sure they stay where they need to be. Once we've completed the soldering process, you can simply go back and clip the excess material. Here you can see all 18 of the 1K resistors in place. Next step is to do the same with the 100K resistors. We take these resistors and we bend each leg down carefully, making a U shape, and then we can go ahead and drop them in the board before we go ahead and solder them up. We repeat the same process for the 100K resistors that we completed for the 1K resistors. Really no difference here. Here we snip the excess once again. Here you can see we've completed all the resistors, all the caps. We're going to now move on to the power jumpers for each one of the Arduinos using these 1x20 pins. We simply go in here and we clip them off as we need them. Here's the length. You can just simply clip them and then we'll drop them in each individual spot and then go ahead and solder them very quickly. Here all the pin headers for the jumpers have been installed. We have to do the same for jumper 10 just above the Raspberry Pi. Here you can see all the pin headers in place. The next item is the Traco 3.3 voltage regulator. You can see the little dot here in the corner lines up to the dot denoted on the board. Simply drop it into place. 3 pins. Just take your time here. You may have to readjust the board, check your work, and then once we're completed here with these 3 pins, we'll go ahead and trim the excess material before moving on to the next step. Here you can see the Traco voltage regulator in place. We'll move on to the RX 5808s for these. And we simply use a quick flux pen to make sure we can easily bridge the solder pads. This is a little tricky, so take your time. Basically you just kind of heat up a little pool of solder, you tack it in, and then you kind of spread it across the pins. So here you can see me going pin by pin, just making sure everything's lined up. You don't need a lot of heat. Same 600 to 650 degrees, and I simply go through and just make sure that the pad and the RX unit have bridged the gap. Here in this next shot I'll get a nice close-up for you. You can see the shiny joints. Here's the same process. Use the flux pen, add a little solder, tack each side down so it doesn't move. And you can see how I kind of pull up the solder and then stretch it over to the RX module. Here I've got them all installed before moving on to the next step. Here we're going to be using these female pin header rows. We basically drop them into these slots that are designed for the Nanos, and this is simply utilized so you can easily service the Nanos. If something burns out, you can simply replace it. So you use 2 of them here. Keep in mind these are 1x20. When you order them, you have to clip them so they fit the Nano. You can see the Nano just drops in. Then we go ahead and we'll tack opposite ends of the pin header rows. This is simply to keep them in place and keep them lined up. You can push them from the other side while you heat those 2 pins to make sure they're well seated. Then we simply just go pin by pin here. Similar temperatures, 6 to 650. Very similar process to what we've done across the entire board here. There's a lot of through-hole soldering, so you'd be a professional by the time you're done with this board. Go pin by pin and check our work, and once it's completed you can go ahead and repeat the process for all the following Nano slots. There is 6 of them, so that basically equates to 12 individual slots. Here you can see the ports are ready for our Nano. You basically just plug it in like so, and they drop in. Here you can see all 6 Nanos. The ports are ready. You can drop in each individual Nano, and it's very easy to service these. You just pull them out, update, drop them back in. Here they're all done. Next step is this 2x20 pin header for the Raspberry Pi. Drops in this port. We simply just tack in the ends, similar like we've done on all the other pin header rows. We go ahead and take our time, do pin by pin. There's not much to it here. so I'm not going to explain much. Just go ahead and finish watching this little clip. So we simply inspect our work here. Everything looks clean, in place. Quickly flip it over to take a look. Everything looks alright. So we've completed the entire portion here. Next step, we'll be moving on to power. Here we're moving on to the power portion. This is what's going to power our Raspberry Pi and peripherals. It's a 5 volt, 5 amp Pololu. We need an XT60. Nothing extraordinary here. I'm using 18 gauge wire to go from the Pololu to the XT60. And then finally we're using a 1-foot USB cable that would go from the Pololu to the Raspberry Pi. Here I'm just clipping the end of the USB I'm not going to use. I think everyone's familiar with how to strip cables. A USB cable has this inner shielding, and also it looks like some braiding to help with strength, and so you don't get crosstalk or data loss. Once you fold back the shielding, you can see basically 4 inner cables. You'll have a positive and negative, and then you have your data cables, probably for transmit and receive. And here I'm just clipping off the portions I won't need, and I'm just leaving the positive and negative. So here we're going to take the positive and negative. You can see the output here on the step-down regulator. So this would go to the Raspberry Pi, and the XT60 or our inbound power basically go on these couple pads, and outbound USB. So basically here what's going on is, we're stripping down the cable, we're making sure we have the correct lengths, so they just barely touch on the pads. This helps us take our battery voltage from, whether it's 3, 4, 5S down to a 5 volt that the Raspberry Pi can handle. So here I'm just basically stripping the ends off, getting it ready to solder. Here I just quickly tin the ends of my cables, make sure they're in good shape before tacking them down. So here you can see I apply a little bit of heat. Here I'm getting the XT60 cables ready. I like to make sure I tin them well, to make sure that the solder has gone all the way through into the braid. So I'm just stripping here with my little X-Acto knife. Usually I have a wire stripper, but I didn't have that handy, so I went with something more practical. On the negative lead, we do the same thing. So both of the negative or ground go side by side, so there's not much issue there for short. Here you got to be careful with the positive. These are pretty tight, so make sure you give it enough room so you don't have any issues. And this is basically what you have. You have the USB on one side, and then you're ready for your XT60 on the other end. So here I've stripped my cable for the XT60. I go ahead and prep for inserting it into the XT60. Make sure I'm getting really good contact. So I've stripped and left a good piece that will make that contact. Do the same thing for the positive lead. Same technique. Just apply a little heat and kind of go back and forth, make sure it gets into the braid. You might have to flip it around a little bit. I wasn't using the biggest tip there, so applying a lot of heat was difficult, but anyway, I got it done. So on to the next portion. Once we tin these, we're going to get our XT60 out, and basically it would go like so. So we drop them inside the ports just to make sure they measure. So what I do is I first kind of fill up this little gap where the wire would sit. I fill it with plenty of solder, and that way I can, once I fill it up, I can just kind of heat it and drop in the cable while it's heated. So here I'm going to go ahead and fill up the other side, and you can see I've taken my XT60 and connected it to a small lead there, and that helps dissipate the heat so you're not burning up your XT60 cable. So that's a little trick I've learned to use, so that heat kind of shoots down that extra piece of cable and doesn't bother you at all and doesn't melt your connector. I went ahead and placed the cable. We're going to do the same thing on the other side. I apply a little bit of heat. Make sure you have your heat shrink on before you close these up. So you can see I have two pieces there in place. So here I'm heating the portion with solder. Use a little extra for heat transfer, and I go ahead and insert the cable. Sorry for putting my hand in the way there. And that's it. I just make sure it's lined up and straight, and I don't want it crooked, so I want it to have good support. So I give it a little heat and make sure it's straightened out there. So here I'm just basically checking for continuity, making sure I don't have any shorts here. So I have my multimeter on continuity mode, and I'm just doing some basic checks here to make sure I'm in good shape before moving forward. I can also check on the USB. Really, the pins are on the inside. Just checking on the outside shielding there for a second to make sure nothing was out of place. And this is always good practice. You know, give it a quick check with your multimeter, and you won't have problems. Here I'm checking the input voltage, so you can see I got a 3S battery hooked up, so I'm getting about 7.6, and I'm checking output, and here's my 5 volts output. It's pretty dead on. So finally, here's the true test. Hooking it up to my phone instead of burning the $30 Pi. I chose to test on my phone. There we go, all set. Thanks everyone for watching. Stay tuned for part 2 where we go over the software portion.